Morning once again, beta. Good morning, girls.
Yes, ma'am.
Good morning, ma'am.
Good morning.
Good morning.
I told you, I mean, we wish each other, but when the recording starts, then also we have to wish each other. Is this
Wish.
okay? So, this is what we had done, remember? I showed you how this litmus looks like, the lichens, from where we get the litmus. This is how it looks like. We have done this. Now, look at it. This litmus paper, see, what is it? This was blue. This paper was blue. Right, beta? It turned red. Is this clear? Anything which is red is acidic. Is this clear?
Yes, ma'am.
Girls, can you hear me?
Yes, ma'am.
It is acidic. Red is danger. You should remember like that. So what will turn red? Blue will turn red. That means it is acidic. Okay. You can see over here. This was blue paper. So this is a blue paper. Can you see this blue paper? It became red. Is this clear? When it is dipped in the solution. Now let's come back to the second one. This is a red paper. What is this? Red paper. It became blue, showing that it is base. So it is BB. That means blue base. Is this clear? Hello?
Yes, ma'am.
Yes?
Ma'am, your voice is coming very slow.
Just a moment. Now?
Yes, now it's proper.
Now it's okay? Okay. Fine. This litmus paper turns blue when it is dipped in a basic solution or alkaline solution. Let's do what types of indicators we have. Read better. Examples of indicator. Read better. Can you hear me?
Yes, ma'am.
Yeah, read better.
Examples of indicator: litmus, paper solution, turmeric, China rose, and
Phenolphthalein.
phenolphthalein. Phenolphthalein.
Phenolphthalein.
Phenolphthalein.
Yes. Got it? See over here, this is litmus solution. What it is, beta? It is solution. And here you can see it is paper, litmus paper. Can you see this litmus paper? Yes? Girls?
Yes,
Yes. This is turmeric. Can you see this turmeric, beta? Yes, beta?
yes, ma'am.
Yes? And this is hibiscus or the China rose. So this is hibiscus or China rose. The other name is hibiscus. This is also a natural indicator, which we call it the jasud. Have you heard of jasud in Gujarati?
Yes,
Yes, this is jasud. Okay, this is a natural indicator. Any problem? We'll do one by one. Let's say turmeric first. You can say turmeric. This is turmeric. From where you get this? We make. We get it from turmeric. That is called halder, and we stain a paper with turmeric. That means we take a blotting paper and put the paste of turmeric on it, and this is what we get. This is the turmeric paper. Is this clear? Now what I will do, I will take this paper and treat it with basic solution and acidic solution. Is this clear? Hello? Is this clear?
Yes, sir.
Yes? All of you can hear me or not? Is that you, Rabia?
Yes.
Okay. Others can hear me? Can others hear me, beta? Because I'm not getting, except your answer, I'm not getting anyone else. That's why.
Yes, ma'am.
Yes, ma'am.
Can you hear my voice? That's what I'm asking you. Okay.
Yes, ma'am.
Okay. Now, this turmeric paper, when I'm treating with basic solution, it becomes red. See, it is just the opposite. Litmus paper becomes red when it is acidic. But with basic solution, it is become red in turmeric paper. So you can see this over here, red. So that means it is basic solution. And in acidic solution, it remains as it is, yellow. Is this understandable? In litmus paper, what we saw, beta? The blue litmus will turn to red in acidic solution and red litmus will turn to blue in basic solution. Is this clear? In litmus paper. But in turmeric paper, what we see that with basic, the yellow will turn to red. And in acid, there will be no change. It will remain as such. Is this clear? Did you understand better?
Yes.
Yes, ma'am.
Yes? Okay. Now turmeric is over. Now we come to China rose. So take a China rose and you prepare the solution. This is an indicator. See this pink color? We get this sort of solution with the help of China rose. So pink color solution you got, that is used as an indicator. Right, beta? So this is the indicator. Now, if you are adding acid to it, with this you add acid, the color will change to orange. Can you see this? And when you add this to it, the color will change to green. Is this clear? Is this clear, beta? Hello?
Yes, ma'am.
Did you understand what I said?
Yes.
Okay. So when I take China rose as an indicator, this one is China rose. And if I add acid, it becomes orange. And if I add base, it becomes green. Is this clear? So if it changes to green, you should understand it is basic. If it changes to orange, then it is an acid. The color differences will tell you whether it is acid or base. Now, how to make this indicator? Please read.
Ma'am, can I read?
Use it.
Ma'am, can I read? I
Okay, read.
soaking China rose petals in hot water creates a solution that can be used as acid base indicator. Acid turns acid turn China rose to red color or pink color. Bases in turn China rose into yellow and greenish color.
Now, how do we make this indicator? So first you have to take this rose, China rose petals. You know what are petals? Petals are these, right? So these are called petals. Do you understand? Okay, the colorful parts of flowers are called as petals. So we will take those petals and put it in hot water. And then after some time we'll see that hot water will bleach the petal and it will take the color of the rose petals, China rose petals. And now that solution will use it as acid base indicator. If I add acid to it, this solution will turn to red or pink color. And when I add base to it, either it becomes yellow or greenish. That's what we saw just now, beta. Isn't it? This is what we saw. It becomes greenish in color, and this becomes orange or red in color. Is this clear?
Yes.
Yes. Now we'll see. These were all natural indicators. Now tell me what are the natural indicators, beta? Tell me the name of the natural indicators one by one.
Ma'am,
Yes.
ma'am, we have to draw this.
No. Did I say anything? You have to just go through the uploaded video. That's it. You don't have to do anything except I tell you to do.
Okay, ma'am.
Now tell me what are the natural indicators? Name them one by one. Hello.
Yes, ma'am.
Give me what are the examples of natural indicators one by one. Can anyone give me the examples of natural indicators? Hello?
Yes, ma'am.
Yeah, give me the examples of natural indicators, better. As it's a part of revision, I've already taught you. So give me name the natural indicators, please.
Turmeric,
Yes, first turmeric, second. Hello, second.
litmus,
Yes,
and
second
China
it
rose.
was. Very good. Now you got it. So all of you understood what are natural indicators. Thank you, Vita. Turmeric, China rose, and it should be on the tip of your tongue. Because now we are going to start with the artificial indicators. So the natural indicators should be clear in your head. Now what are we going to do is two types of natural indicators, phenolphthalein and methyl orange. Is this clear? Yes, better?
Yes, ma'am.
Okay. In your syllabus, it's only phenolphthalein, but I'm giving you, I'm always giving you extra, I'm telling you. I'm sorry, but I'm giving you extra. Methyl orange is not mentioned in your syllabus, but I'm giving you. Okay. And this is also a type of indicator. Now, what you see over here is all types of chemical solution. If you take the blue litmus solution, it changes to red. But if you put in basic solution, there is no change. You take red litmus solution, in acid solution, there is no change. But in basic solution, it becomes blue. Is this clear? This we already know. Yes, children? This we already know about litmus solution, beta?
Yes, ma'am.
Yes? Okay. Now we come to methyl orange. With methyl orange, when I put it in acid, it becomes red. And we put in basic, it becomes yellow. And well, what is the neutral solution called as? That means there is no, the pH is 7. What is the neutral solution, beta? pH is 7. So methyl orange remains orange in neutral solution. If it is phenolphthalein, in acid solution it is colorless. But in basic solution it becomes red. And neutral solution also it is colorless. Is this clear? Now, Don't get confused. You may not take this, leave this, but this is important. Is it understandable? If you understand it in a tablet form, you don't have to learn everything. Right? In short, you can learn everything. Is this clear? So methyl orange is red in acid, yellow in basic. Phenolphthalein is colorless in acid, but red in basic. Or you can say pink. Actually, it says pink in color. Which color you will say? Pink in color. Is this clear? Hello?
Yes, ma'am.
What are the difference in acid and base? Please read.
Difference in acid and base. Acid, sour in taste, base, bitter in taste. Turns blue litmus paper red, no effect on blue litmus paper. No effect on red litmus paper. Turns
Litmus.
red litmus paper. No effects
Then
on brick paper. Turns turmeric paper to red. Turns China rose solution to dark pink. Turns China rose solution to green.
thank you. Now the difference of acid and base. What is the taste? Sour. Acid tastes sour. We know already. Base tastes bitter. This also we know. Yes or no? Do we know this or not?
Yes.
We know that. What is the other property? That it is changing blue to red. Right, beta, in acid? Blue to red. Agree? If I put the blue litmus paper in base, no change in color. Is this clear? Blue remains blue in basic solution. Is this clear, beta? There is no change in color. Second, if I take red litmus paper and dip in acid, there is no effect. But if I put red litmus in basic solution, yes, the red will turn to, is this clear? Is this clear? Hello?
Yes, ma'am.
Yes, ma'am.
Is this clear? Understood now? Fine. Next one is, if I put acid on turmeric paper, the turmeric paper remains yellow. Agree? Just now I showed it to you. Just now we learned regarding turmeric paper. The turmeric paper remains yellow when it's put in acidic solution. You agree? But in basic solution, it turns red. For example, you get stained when you're eating, uh, the food falls on your dress, right, beta? When it goes for wash, after wash, it becomes stained to red, orange. Have you observed that? The uniform becomes orange. There's a stain of orange. When you accidentally, your food falls on a dress, and when it goes to wash, it changes to orange or red. Have you observed that any time? Hello, hello, girls. Hello, hello.
Yes, ma'am.
Yes. Okay. Then let's come to China rose. So if I'm putting in acid, it becomes red, dark pink, or orange. So China rose will change to red, dark pink, or orange. And in base, it will turn to green. Is this clear? So all the things are cleared up, beta? Okay? This you can make a table, this one. Acid and base, difference in acid base. Everything is written over there. So in one glance, and you know everything about acid and base. This you can write in your fair book. Okay, beta?
What, ma'am?
This you can write in your fair book. The slide number
Okay.
Okay,
24.
ma'am.
The slide number 24. Differences in acid and base. It will be very easy for you to understand. Okay, all of you, and the ones who are absent, please let them know as well.
Ma'am?
Can you see? Can you see the number over there on your screen? Is there any
Yes.
number on the screen? Which one is that, beta? Which is the number on the screen?
Ma'am?
24.
24. So remember 24. Okay. This you have to write down.
Ma'am?
Yes.
Ma'am,
What is saying?
we don't write in rough book.
For me, there is no rough book. It's only fair book only. Nothing else. In fair book only you have to write. Now the next part is we have done acid, we have done base. Now what we are going to do? Neutralization. What are we going to do with the neutralization? What is neutralization, by the way? If we take an acid and we add something to it, the effect of acid is gone. That is called neutralization. And I get something different. That is called salt.
Ma'am, can I read?
Use it. Who wants to read better?
Ma'am, can I read?
Now who wants to read? That's what I'm asking. What's your name?
I know.
I know, but you have already read. Let other come. Okay, let other take part. Better. Yes, who will? Who wants to read better? So can you want to read better? Hello. Okay, I now continue then if no one wants to.
Okay, ma'am. Neutralization. When an
Neutralization. Say
neutralization.
neutralization.
Neutralization. When an acidic solution is mixed with a basic solution, both the solution neutralize in the effect of each other. The reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat.
What are we doing? We are adding acid solution and a base solution. Right, beta? In certain proportion. So we are adding acid and base. What are you doing? We are neutralizing the effect of each other. So base is working on acid, vice versa, and acid is working on base. What are you doing? Acid is cutting short the basic features, and base is removing the acidic features of acid. Is this clear? It is nullifying the effect of acid. Base is nullifying the effect of acid, and acid is nullifying the effect of base. This is called neutralization. So, when there's a reaction, when acid is reacting with base, it is called as neutralization. It is called as neutralization. And what is Another thing that we get salt and water. So whenever there is any neutralization reaction, we get salt and water which is produced with also the evolution of heat. So if you can take a conical flask or a test tube and you are doing this neutralization reaction over there, if you touch the test tube or the conical flask, you will find that it is warm. Do you get me? It is warm. You will find that. Is this clear? Hello, is this clear, Peter?
Yes, ma'am.
Yes, ma'am.
Now see, reaction. Acid plus base. So what we get, Peter? What we get? Salt and water. And heat is evolved. Right, Peter? Heat is evolved. Let's say which is an acid. This HCl is an acid. Base is sodium hydroxide. Salt is sodium fluoride. Water is water. Here, when we are taking acid and base, again I repeat, hydrochloric acid, it is HCl. This is an acid. Right, beta? Sodium hydrox, that is NaOH, is the base. Gives sodium chloride, NaCl, as salt. Water, that is H2O, is water. This is the neutralization. Any problem? Was any problem?
No, no.
Read it. And let me know what extra you got from this slide.
Can I continue, ma'am? I know.
Yes, yes.
Neutral, neutralization. The reaction between acid and base to produce salt and water is called neutralization.
Neutralization, say like that. Neutralization. Say with me.
Neutralization.
So,
The
well done.
equation of this reaction is written as acid plus base is salt plus water. In neutralization reaction, a new substance is formed called salt. Salt may be acidic, basic, or neutral in nature.
Neutral. So, whenever you are reacting acid and base, what we get beta? Salt and water. The whole process is known as neutralization. You follow me?
Neutral,
Do you follow me now? Any problem? This is revision we are
no,
doing. Okay. Secondly, how does it look? Acid plus base gets salt and water, right, beta? Hello, hello. Can you hear me? Can you hear me, beta?
yes,
Okay.
Yes, ma'am.
In this reaction, a new substance is formed that is called as salt. Right? Now, what is the features of salt? That salt can be acidic, can be basic, or can be neutral. Any problem? Any problem with that?
ma'am.
See, what is happening over here? Acid and base is mixed in this conical flask. And what we get? Salt and water. What are we
Salt.
getting? What is the phenomena? What are we doing?
Correction.
All of you understood better?
Yes.
Yes, ma'am.
I'm trying to make things easy by, repeating the slides in a different manner so that when you look at it, you understand it better. We'll see the examples of neutralization. Read better.
Example of neutralization. Hy- hydro- hydrochloric acid HCl plus sodium hydroxide NaOH, sodium chloride,
Gives. You can see
and
arrow over here better. Can you see the arrow?
yes,
What does that
yes,
mean? It gives. What you will say? Gives.
gives
What it gives?
gives sodium chloride
Chloride.
NaCl plus water H20.
H2O. What do you say? H2O. So this is the formula. These are the formula of the elements. So you can say molecular formula. Because now you have to learn all these things because in 8th standard, uh, these are there. So things will become easy for you if you understand right now. What is hydrochloric acid, beta? HCl. What is hydrochloric acid?
HCl
What is sodium hydroxide?
NaOH
What is sodium chloride?
NaCl
You understood one thing? Sodium Na. Sodium Na. This is what you understood? What is the symbol of sodium? Na. Clear?
uh,
Okay. Then we come to water. What is water? H2O. Actually, it is written like this, beta. H2O. But when you type it, you cannot write it this way. So this comes like that. Fine. So over here. Equation is HCl is acid, sodium hydroxide is base, and we got NaCl plus water. What we are doing? Acid is HCl, base is NaOH, we got salt is NaCl, and this is water. Clear? And now if you touch this flask, when you touch this flask, what you will find? That it is hot. What you will find better? It is hot. Please raise. Please read it better. Hello?
Yes.
yes,
Start
ma'am.
reading. Please start reading better.
In the process of neutralization, heat is always produced or evolved. The evolved heat raises the temperature of reaction mixture.
Whenever you are doing neutralization, what is produced? What is produced better?
Heat, heat,
That means if you touch the flask, you will find it warm. This heat, what it is doing? It is raising the temperature of the mixture. Which mixture? The reaction mixture. So it raises the temperature of acid and base, and whatever salt we get is along with the heat evolved.
neutralization reaction. A neutralization reaction is the is the reaction of an acid with a base to produce salt and water. Example H2 H2SO4 plus NaOH gives NaHSO4 plus H20.
O, H2O. What you will say?
H2O.
So again, we are talking about the neutralization reaction. Acid and base are reacting. And what is produced with the salt and water. And along with the salt and water, what are we getting? Yes, you're right. We're getting heat.
Heat.
Second example, yes, beta. Second example, what we're taking is sulfuric acid. What is H2SO4 beta? Sulfuric acid. What you will say? Say beta. Sulfuric acid.
Sulfuric acid.
Sulfuric acid.
Sulfuric acid.
This is H2SO. Then we have NaOH. What is NaOH? Do you know that beta?
Sodium hydro
Hydroxide.
hydro
Sodium hydroxide. What you will say?
sodium
Sodium
hydroxide.
hydroxide. Done? Done beta? And this is sodium hydrogen sulfate or sodium bisulfate. What you will write? Sodium
Sodium
hydrogen sulfate.
Yes, ma'am.
Okay. And what else is liberated? Water. You know water? You know water of plus heat. Is this
heat.
clear? Is this
Yes.
clear?
Yes.
Yes.
Has it become simple now? Neutralization.
Yes.
Yes.
Now we'll see where we are finding neutralization in the body. We are going to find out the examples of neutralization in human beings. Start. If you can
Digestion and
explain, and if you can explain, well and good. Read one sentence if you think that you have the answers and you know about it, then please read better. Is the time up? Yeah, the
yes.
time is up better. Time is up. I just realized it. And so that you have to, stop me better. Sometimes I forget to keep a record. So you have to let me know. Okay, we should not take someone's time better.
Yes, ma'am.
Okay, thank you. I hope you have understood today's lecture nicely.
Yes. Yes, ma'am.
Have a good day and enjoy.
Bye, ma'am. Have a wonderful